Welcome to the next session on ANSYS CFD tutorials. In this session, we will analyze a T-shaped pipe for its CFD analysis. We will start by double-clicking on Fluid Flow Fluent. I will go to Geometry and right-click. Since I already have the geometry made with me, I'll directly import the geometry. Then I'll double-click on geometry itself because I want to add the fluid here. You can see here it is one part, one body. It's just one solid. So I'll go to Tools, Fill. I'll select this inner surface where I want to add the fluid. I'll click on Apply and Generate. So now you can see there are two solids. This is the pipe one and this is the fluid here. So I'll rename the first one as wall and the second one as fluid. The geometry is completed here. Then I'll go to the main screen. I'll go to Mesh and double click. I'll first go to Mesh and you can see the element size is given. I will change this to 0.01 meter and generate. Now meshing is done, so I will give names to inlet, outlet and the wall. Now in the previous analysis, we have taken inlet as this end. Today we'll take this end as the outlet. So let me choose face and I'll go to right click, create name selection. This is the outlet. This is the inlet 1. And this end is the inlet 2. This is the wall surface. So I'll select both, create name selection. This is the wall. You can check here, all the 4 have been created. Now once this is done, go to mesh once again and update. You will get the message over here, the mesh translation to Fluent was successful. Once this is done, meshing is complete. I'll close this window. Then I'll go to Setup and double click here. I'll choose double precision and start. Here I'll choose gravity. In the y-axis, I'll give the value as minus 9.81 meter per second square. Then I'll go to materials, fluid. I'll double click on air. I'll go to Fluent database. Here for fluid, I'm going to choose water liquid as the material. Copy, close. Then I'll go to solid. I'll double click on aluminium, Fluent database. I'll change the material type to solid. Steel is the material. Copy, close. Then I'll go to cell zone conditions, fluid. I'll double click on this fluid option. I'll change the material name to water liquid, apply, close. Then I'll go to solid and double click on wall. I'll change material to steel, apply and close. So we have set the material. Next, I'll go to boundary conditions, inlet. For inlet 1, I'll give the value of velocity as say 3.2 meters per second. Apply and close. For inlet 2, I have to give another boundary condition. So I'll give this velocity as say 2.6 meters per second. Apply and close. Once boundary condition is given, I'll go to reference values. I'll compute from inlet 1. Reference zone is the fluid. Then I'll go to initialization and double click. I'll choose standard initialization, compute from all zones and initialize. So once this is done, I'll go to calculation activities, auto save every iteration. I'll change this number to say auto save. I'll double click here. So I'll change this to say 50. Okay. Once this is done, I'll go to run calculations. Say the number of iterations I give as 500 and calculate. So you can see the calculations are complete. The solution has not converged as you can see here. Few more iterations would be required, but I leave it to here itself. If you want, you can increase the number of iterations and wait for getting the converged solution. So once this is done, you can either see the results here or you can go to the main screen here and here you will get the results. You can double click on results. I'll first go to inlet and double click here. I'll go to render and change the transparency to 0.9. Apply. I'll do the same for inlet 2, outlet, wall and wall 1. Once this is done, I'll go to streamline. Okay. I'll start from, now I want to choose both the inlets, so I'll click here. I'll press Ctrl and select inlet 1 and inlet 2. Okay. Apply. I'll just click on animation. I'll change type to sweep animation. I'll select streamline 1. Remove forever loop and increase it to say repeat 4 times and play. In the previous analysis that we had done, this was the inlet and these two were the outlets. So water was entering from here and branching into the two pipes. Here you can see water is entering from the two pipes and it is moving into one and flowing out. Now you can observe that the velocity of one of the pipe was more than the other one. So this speed is more, as you can see, as compared to this one. This was around 3.2 and this was 2.6. So because of the two variation, you can see the variation of speed also of the flow. So this is done. I'll close this and I'll remove streamline 1. I'll click on contour. Okay. I'll select here contact region TRG. Pressure, I want to see the local value. I'll go to render and remove this show contour lines and apply. Now you can see the result. The pressure here is more as compared to the pressure in this zone. this pressure has become less because the velocity will be highest here. And you can see here the pressure is minus 2.57 Pascal. This is showing you vacuum pressure. And the highest value is in these zones. This is green, so you can check the value from here. It is somewhere in this zone. Now we want to see another contour. So I'll again remove this contour one. I'll click on new contour. I'll select contour region TRG. Variable is velocity. Range is local. I'll go to render and here I'll remove show contour lines, apply. Here the velocity is showing minimum because the pressure was highest. Where the pressure will be minimum, you will see more of velocity, that is in this zone. It is reddish, it is 8.36 meters per second. In the main screen, you will be able to see highest value is 8.36 and lowest is 0.063. That is over here, where the pressure value was highest. So that's how you analyze a T-shaped pipe for 2 inlets and 1 outlet. With this, I end the session. I hope you have understood the analysis. If you have any doubt, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.